Hello, everyone. I'm really happy to be here today at CC. My name is Nicolas, and I'm a software engineer at Spiko. And today we'll talk about how we manage over $1 billion of real-world assets on 7 different blockchains. So, first of all, what is Spiko? So, Spiko is a new regulated investment firm licensed by the IMF in France. So, we manage tokenized financial products on public blockchain. Our smart contracts are open source and the audit reports are available online. Basically, the financial products that are tokenizing our flagship today. It's money market fund product. It's T-bills, and as of today, we have practically $1.5 billion asset under management, which makes us the third biggest actor of tokenized T-bills globally. So I told you that we are live on 7 blockchains. Here they are. So we are live on 5 EVM-compatible blockchains, namely Ethereum, Polygon, Arbitrum Base, and Etherlink. But we're also live on Starknet, and we live on Stellar. We plan to be live on many more blockchains, and there are several coming up this year. But this setup brings us a very technical engineering challenge. How we can safely operate on 7 blockchains in a consistent manner without relying too much on blockchain-specific implementation. So to answer this question, I need to talk to you a little bit about our goal and our vision. For us, blockchain, at first, it's a concept more than an implementation or a technology. We want to rely on core blockchain property, such as transparency, auditability, security, and traceability. So that's the main principle on which we want to build Spiko, and that we rely on this principle. So blockchain is really our core technology. Everything in Spiko is derived from the blockchain. The blockchain is really our single source of truth. So in order to be able to design such infrastructure, we need to have a standard blockchain-agnostic smart contract architecture, which have the same separation of consent, the same role, the same workflow, the same life cycle. That's for the on-chain part, but there is also the off-chain software component that also need to be blockchain agnostic and generic. The idea at the end is to be able to add a new network, not in months, not in weeks, but in days. And it should be as simple as knowing and implementing smart contract in a given technology for a given new blockchain, and implementing a bunch of software component for all our off-chain interaction. So here it is, our smart contract architecture. So as you can see, we aim it to be quite simple. It's composed of four main smart contracts. The most important one is the token smart contract. So the token smart contract represents the one financial product on our platform. So we have one smart contract token deployed per financial product. For example, I talked about money market fund. We have Euro money market fund, which is called UETBL. It's a smart contract, a token smart contract, and we have a dollar money market fund, and it's also a token smart contract deployed on-chain per network. If you're familiar with the EVM ecosystem, it can be seen, and it's actually the implementation for the EVM implementation, as an ERC20 permission token. But really, that's the EVM implementation, and we want to see it as a generic token implementation. So there is an instance of the token smart contract, and then we have the 3 other smart contracts, the minter, the redemption, and the permission manager smart contract, which are singleton, so there is only one instance of each of these smart contracts per network, and they are the smart contracts that handle the security and the operation of the fund on chain. So this smart contract ensure us that we are operating the fund properly and securely on chain. And they're handling, each of them are handling their own flow, so the minting flow, the redemption flow, and the permission flow. So we will look a little bit deeper on each of these smart contracts to give you an idea of how it works and what guarantees it gives us. So to begin with, the permission manager contract. It's one of the most important, actually. It gives us, it's really the central permission authority. It can be seen as an access control manager for all the other smart contracts, but also address. As I said, our token are permission token, so we need to whitelist and all the investors that have wallets and want to invest on Spiko. So it's not a complete list of all the roles that can be granted in our setup, but some of them here. And as you can see, there are several personas in our setup. You have the multi-sig, some smart contract, the relay wallet, and the investor wallet. So the multi-sig, it's really our team operational wallet. So that's really the admin. It's a human-operated wallet, so it's not programmable. And it's the wallet that can grant the sensitive role to the other part of the system. It can grant the role for the smart contracts, different smart contracts which have dedicated role, which allows them to efficiently go through the different flows, the redemption flows and the minting flows. But there are also the relay wallets. The relay wallets, they are operational wallets, but which are managed programmatically by Spiko app. So this wallet, the relay wallets, are initiating all the operation of our fund. For example, they are dealing with the whitelisting operation, so they have the whitelister role, but also they are initiating all the operation that will then interact with the other smart contract, for example, with the mint initiator role. And then we have the investor wallet, of course, which have the whitelisted role. It's quite important to have it in mind because our setup is hybrid, so we handle on the same time custodial wallets, so investors that delegate the custody of their wallet to us, and self-custodial, so our system should work efficiently with both cases. So the minter smart contract. So to follow this role setup, let's have a look at the minter smart contract, which is using this permission setup to effectively control how we can mint token in our system. So the minter smart contract, it should be seen as our safeguard against infinite mint problem, bugs, or attacks. So internally, the minter smart contract holds a daily limit for each token. So basically, each day, you can only mint a fixed amount of token automatically. And then it needs to go through a two-phase approval. So basically, our operational wallet, as we've seen before, which have the mint initiator role, can interact with the minter smart contract. it will try to initiate a mint. For example, when we've received money in the fund and we want to issue tokens that are related to this subscription to the fund, and the minter look at its internal state and look at if it's under the daily limit. If it's under the limit, it passes through and it invokes directly the mint function of the token, and that's it. But if it's over the daily limit, it's blocked and it's logged inside the internal state of the minter smart contract. Then it needs human intervention from the multisig. That is the only one which have the mint approval role, which is really the safeguard of all this setup, and which is the only one who can approve or cancel a mint operation that has been blocked. How do we know when a mint is blocked or not? The Minter smart contract, like all our smart contracts, have a standard set of blockchain events that can be logged inside the blockchain. It's event in EVM, and it's a standard component of all the blockchain that we are operating on. And so we monitor for the mint initiated event. There is a mint blocked event, and with all these events, we know when we should intervene with a human operation to unblock the situation. The other piece of the puzzle is the redemption contract. So the redemption contract, it's quite similar to the minter contract, but it serves another purpose to help us to mimic how our fund is working, because at the end we're working with real world assets, so we have real world obligation and constraints. So and basically we're working with wallets of investors that are custodial, that we own, and wallets that are self-custodial, that we don't own. So we want an experience that is fluid and simple for investor. So we want them to be able to redeem with one operation, and then they should not care when the fund is really doing and executing the redemption, depending on how the fund is working. For us, for example, nowadays we have one fund execution per day, so we have one time each day where we can execute the redemption. So to tackle this problem, we have also a two-phase workflow. First of all, the investor will transfer its token to the redemption contract, and at this phase, we can see the redemption contract as some kind of vault, segregation account, where the funds are segregated and waiting to be redeemed effectively. And so it's stored in the internal state of the redemption contract, and it's waiting from the operator to execute it effectively. And then when we effectively, with the fund, process the different redemption and to leave the blockchain to go to the real world, our operational wallet call and interact with the redemption contract to execute the redemption effectively with the proper ID to call the burn function of the token. So there is really two flows, two main flows, the minting flows and the redemption flows. And these contracts are the only ones that can interact with the token sensitive function directly, namely the mint and the burn function. So that's for the on-chain architecture. What about the off-chain story? So for our off-chain architecture, we wanted to follow the same philosophy. So the idea was to implement a stack and an application that is the most standard Web3 application that we could think of. So the components are what every blockchain application should have, namely the rolling infrastructure and indexing infrastructure. But what we wanted to focus on is that, as I said, blockchain is our core a core infrastructure. We rely entirely on the blockchain. So it's really a core business, technology for us. And so we need to own all the core logic of the interaction with the blockchain. So we wanted to limit as much as possible our exposition to third-party provider. So basically, we have two third-party providers that are really thin layer. The first one is our wallet provider, which nowadays is Defense, and which can be seen really as a key management system. Basically, it's our blockchain primitive provider. We call it to sign transaction, and that's it. So that's really a signing function provider. And the other third-party provider is the RPC provider. It's mainly a node of the network, and that's it. All the rest is in-house. The relay and indexer have been developed in-house to own really the broadcasting logic, which is different from every blockchain, with different way to ensure unicity, to ensure repeatability, etc., and to own completely the indexing part, which also is very blockchain specific. Also, the idea was to be able to have as much traceability as possible. So every time we can do it, we try to match all the events we get back from the blockchain to the transaction we're sending. That making really a loop that allows to know perfectly everything that is going on chain and everything that has been initiated by us very easily. So Spiko app, the Spiko system broadcasts the transaction through the layer. So all the blockchain is abstracted from all the other part of Spiko system. And the layer talk to the blockchain and send the transaction, and then the event come back through the indexer, and then hydrate all the Spiko service. From the point of view of Spiko service, it's really only events that exist. The rest of the blockchain does not really exist. So to conclude, what we've learned when we implemented this cross-blockchain design is that really blockchain, it's a concept. You really don't want to rely on specific implementation or specific technologies that change, the standard change, and there are new blockchain that can pop every time. But if you rely on the concept of blockchain, you can redesign an application that is that can grow and scale through time to the current technology, but to the next technology that are to come. Thank you very much. If you want to deep dive a little bit, all our smart contracts are open source, so you can find them on our GitHub organization. We have also a quite active tech blog, and we post quite often all the news about the latest smart contract development or other cool computer science stuff. So do not hesitate. And by the way, we are hiring. So if you're up to the adventure of real world assets, let's talk. Thank you very much, and I'm be happy to answer all the questions.
What led the decision to roll out into 7 blockchains? Was it demand-driven? And the second question, small question, is how much of your clients are self-custodial at the moment?
So to answer to the second question, I would say that most of our clients, that's really one of the strengths of Spiko, is that we're bringing Web2 people to Web3 environments. So lots of our clients are self-custodial because they're from this environment. So I would say mainly like 5 to 10% are self-custodial, and the rest are custodial customer. And what drives us to integrate new network? I mean, with this architecture, it's mainly an ecosystem and an advantage for us. I mean, it's like Microsoft. We can be everywhere if we want, because for us it's not hard to integrate a new network. What drives us at the moment, it's demand, it's collaboration, it's integration in DeFi environment. So that's all these criteria that have driven us to integrate with new network. But basically, it should be, and it is now effortless for us to go and to integrate with a new network. Thank you very much.